Hello dear students, welcome back to the chemistry online class. In the previous video, I have taught you about modern periodic table, okay, how to draw the periodic table and what was the structure of periodic table, who gave that uh, modern periodic table and in which law the modern periodic table depends. Okay, so all those things I explained in the previous video. Today's video I'll continue from that section only. Okay, so this is the outer structure of modern periodic table. Okay, so total it has 18 groups mean vertical columns and 7 periods. Periods means horizontal rows. Okay, in first position we have hydrogen. Here we have hydrogen. Okay, next in this 18th position we have helium. He stands for helium. Okay, for that lithium, beryllium, boron, lithium, beryllium from 3 to 12 it will be empty. Okay, from 13 boron, carbon, nitrogen, oxygen, fluorine and then neon. After that sodium, magnesium, this remains vacant. Okay, from here aluminium, or argon. So aluminium, silicon, phosphorus, sulfur, chlorine, argon. After that potassium, calcium and so on. Okay, this is copper Cu. Okay, K means krypton. Okay, okay, here there will be francium. Remaining there are so many elements. Okay, you feel those elements. Uh, okay, so this was the basic structure of modern periodic table. Okay, so you refer your book for the proper periodic table. Okay, so I have filled till this lanthanum. La stands for lanthanum. Its atomic number is 57. Okay, now there are some silent features for this modern periodic table. Okay, so number one, you write on the question, what do you mean by groups and periods in the modern periodic table? So the answer will be the vertical columns in modern periodic table are known as groups. Total there are 18 groups. This group 1, group 2, group 3, group 4 till 18. In total there are 18 groups numbered from 1 to 18. Okay. Next is periods. The horizontal rows in the modern periodic table are known as periods, and total there are 7 periods. Okay, numbered from 1, 2, 3, 4, 5, 6 and 7. Numbered from 1 to 7. So you write like that. Okay. Next question, you make it. See, before that there are specific names for this different groups. Okay, so let's discuss that one. Write down question. Okay, how to write the question? You write it. Mention the specific names given for the different groups of modern periodic table and also write the reason for giving the names. Okay. So question is, mention the names given for different groups of modern periodic table and give the reason behind their names. Okay. So group 1, let me erase this. Sodium, magnesium. Okay, let me erase this one. names of, you write on the heading, okay, names of various groups of modern periodic table. Number 1, group 1. The elements of group 1 are known as alkali metals. Okay, the elements of group 1 are known as alkali metals. Reason is because they form strong alkali when reacted with water. Okay, so when these elements, hydrogen, you forget about hydrogen, except hydrogen, lithium, sodium, potassium, rubidium, cesium, and below that we have francium. Okay, they are said as alkali metals, AlKali. Group 1 is AlKali, alkali metals, because they form strong alkalis when reacted with water. Alkalis means the bases which are soluble in water. Okay, so example I'll give of sodium. Example, when sodium is dissolved in water, so it forms sodium hydroxide, NaOH, and hydrogen, H2. Okay, so this is strong alkali, strong AlKali. In similar manner, this lithium, below sodium we have potassium, below that we have rubidium, after that we have cesium, and below that we have francium. So all those elements reacts with water to form strong alkali. Okay, so this is sodium reacts with water to form sodium hydroxide and hydrogen gas. This is gas, so you can put upward arrow. So group 1 elements are known as alkali metals, and reason behind that is because they form strong alkalis when dissolved in water. Okay, and you can give this example also, this reaction. Now let's move on to group 2. Next is number 2, group 2. Group 2 elements. Group 2 elements are known as alkaline, AlKali, alkaline earth, EARTH, earth metals. Alkaline earth metals. The reason behind that is they form weaker alkali with water. Okay, they form weaker alkali with water. So example of this alkaline earth metals is this beryllium, below that we have magnesium, below that we have calcium, and so on. Okay, so beryllium, magnesium, calcium, they belong to group 2 and they are known as alkaline earth metals. And for example of alkali metals, you give this one. Okay, lithium, sodium, potassium, rubidium, cesium, and francium. Reaction also you can give. Reaction, magnesium Mg plus water, H2O, gives magnesium hydroxide, MgOH whole twice. This 2 comes from here. Okay, valency of magnesium is 2, so this 2 comes here plus hydrogen gas. Magnesium hydroxide, it is weaker alkali. Okay, so the name given for group 2 elements is alkaline earth metals. So group 1 is alkali metals, group 2 is alkaline earth metals. Okay, now next, number 3, group 3 to 12, here to here, this 3 to 12, this. The elements of group 3 to 12 are known as transition elements, TRANSITION, transition elements, ELEMENTS, elements. Okay, the reason is their properties is the intermediate between the properties of this strong metals and strong non-metals. They lie between metals and non-metals, so they are said as transition elements. Okay. So suppose if question comes, what are transition elements, then you say the elements which are present in group 3 to 12. Otherwise, the elements of group 3 to 12 are said as transition elements. The reason is their properties are intermediate between the properties of strong metals and the strong non-metals. Okay. And suppose question comes if like this, oh, what are alkali metals? Give some examples. Then alkali metals are the elements of group 1. Group 1 elements are known as alkali metals. The reason is they form strong alkali when dissolved in water. Okay. Example you can give this lithium, sodium, magnesium, lithium, sodium, potassium, and so on. Okay. Next, we have reached here. Now this one, 13, group 13, number 4. Number 4 is group 13. Group GROUP, group 13 is known as carbon family, FAMIL family. So the elements of group 13 is known as carbon family. Otherwise, group 13 is known as carbon family because the first element of this group is carbon. Sorry, this is group 13 is boron, not carbon. We have boron here, boron family, BORON, boron. Okay. So the elements of group 13 are known as the elements of boron family because the first element of this series is boron. Okay, this first element is boron. Similarly, number 5, group 14 is known as carbon, CARBON, carbon family because the first element of this group is carbon. Okay. In the similar manner, we have group 15. Group 15 is nitrogen family, NITROGEN, nitrogen family. 7. Next, oxygen family. Group 16, OXYGEN, oxygen family because the first element of this group is oxygen. Here 16 is first element is oxygen. Okay, so it's known as oxygen family. Next, group 17. Group 17 has a specific name and that is halogens. Okay, number 1, 2, 3, 4, 5, 6, 7, 8. Okay, in 8, group 17 is halogens, HALOGENS, halogens. The elements of group 17 is known as halogens. Halo means salt, gens means formula. Okay, so the reason is the elements of this group 17 when reacted with this elements, these metals, they form salt. That's why they are known as halogens or salt formers. Okay, so group 17 elements are known as halogens because they form salt when reacted with the elements of group 1 and group 2 or the metals. Okay, group 1 and group 2, they are metals. So when this elements of group 17 reacts with metals, they form salt. That's why they are said as halogens. Halo means salt, gens means former. Okay, so salt former. Next, group 18, GROUP. This is number 9. Okay, group 18. Group 18, they are known as inert, INERT, inert gases. Inert gases or zero group, ZER, or zero group elements. or noble gases also. NOB, noble gases. This spelling I am not sure. Okay, check it. It might be NOBEL or BLA. So group 18 elements are known as inert gases or zero group elements or noble gases because their valency is zero. This valency is zero and they don't take part in a chemical reaction. That's why they are said as inert gases. Inert means which does not react. Inert means which does not take part in a chemical reaction. Okay, does not take part in a chemical reaction. So we have completed this one. Group 1 elements are known as alkali metals because they form strong alkalis with water. Group 2 elements are known as alkaline earth metals because they form weaker alkalis with water. Okay. Group 3 to 12, they are known as transition elements because their properties are intermediate between the properties of this metals and non-metals. Okay. Next, group 13 elements are said as the elements of boron family. Group 13 is said as boron family. Okay, because the first element of this group is boron. Similarly, group 14 is carbon family. Group 15 is nitrogen family. 16 is oxygen family. 17 is known as halogens. Group 17 elements is known as halogens. Halo means salt. Gens means former. Okay, so this group 17 elements, when they react with metals, they form salt. That's why they are said as halogens. Okay, next, group 18 elements, they are known as inert gases or noble gases or zero group elements because they do not take part in any chemical reaction. Okay. Next, we have number 9, number 10. Inert transition elements. INNER, inert, TRANSITION, transition elements. Inert transition elements. Lanthanides, okay. Lanthanides and actinides. Lanthanides and actinides, which are kept separately in the modern periodic table, are said as inert transition elements. Okay, so if you see the modern periodic table properly, there is a small box like this below this main table. Okay, and here some elements are kept. First, lanthanides and second is actinides. Okay, lanthanides means atomic from atomic number 57 to 71, and actinides means from atomic number 89 to 103. The elements from atomic number 57 to 71 and 89 to 103, they are kept separately in the modern periodic table. These elements are known as inner transition elements, and the elements from atomic number 57 to 71, they are said as lanthanides. Okay, because the first element of this series is lanthanum with atomic number of 57, and the elements from atomic number 89 to 103 is said as actinides because the first element of this series is actinum with atomic number 89. Okay, so no need to write all those things, just write it. Inner transition elements, lanthanides and actinides are said as inner transition elements. That will be sufficient. Okay. Okay, now this group 1 and group 2, they are also known as S block elements because their outermost orbital is s orbital. Okay, that is not there in your syllabus. You have to study about this orbitals s, p, d and f orbitals in higher classes. Okay, in class 11, class 12 you have to study. So for now, just remember that this group 1 and group 2 are next number 10, number 11. Okay, group 1 and 2 is said as S block, small s. Okay, S block elements. This S comes from orbitals. Okay, you have done orbits only. See, an atom consists of nucleus, neutron plus proton. Okay, here there will be orbits: first orbit, second orbit, third orbit, and so on. This orbits, it will be distributed into finer sections. Okay, these orbits will be divided into finer sections, and they are called as orbitals. S orbitals are s orbital, p orbital, d orbital and f orbitals. Okay, so that you have to study in higher classes. Just remember group 1 and group 2 elements, this and this, they are called as s block elements. Number 12, group 13 to group 13 to 18 said as p block, small p. Okay, block elements. 13 group 3 to 12, 3 to 12 d block elements. Next 13, 14 lanthanides and actinides or inner transition elements. Lanthanides and actinides, actinids. Actinides, they are said as F block elements. Okay, so you make a proper note of this names of various groups with region. Okay, now let's move on to the classification of periods or the names given for different periods. Okay, so you write down question. State the names given for various periods of modern periodic table and give reason for that also. Okay, so number 1, first period is said as shortest, shortest, shortest period. First period is called the shortest period because it contains only two elements, that is hydrogen, H means hydrogen, and next is helium, He. In first period, with left hand side you have hydrogen and on right hand side corner you have helium. Okay, so first period is known as the shortest period because it consists of only two elements, that is hydrogen and helium. Okay, number 2, second and third period. Second and third period is known as short periods because they this periods, second and third period, contains 8 elements in each. Okay, in second period you have 8 elements, in third period you have 8 elements. That is second. Okay, this one second. In second period, elements are lithium, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and third period, elements are sodium. this. Second and third periods, they contain 8 elements in each. Okay, that's why they are known as short periods. Number 3, long. Okay, next is third, fourth and fifth. Fourth and fifth. They are known as long periods because in each of this fourth and fifth period there are 18 elements. Okay, so you can give the names of the elements also. For example, you can give some names. Okay, fourth and fifth period is known as long periods. Okay, because in each of these periods there are 18 elements. Okay, next, number 4, sixth period. Sixth period is known as longest period since it consists of 32 elements. Sixth period consists of 32 elements, and ultimately 7th. Seventh period is also known as longest period, and sometimes it is also known as incomplete period. Okay, incomplete period because some gaps are there in seventh period. So sixth and seventh period, they are known as longest periods because there are 32 elements in each. Okay, and sometimes the seventh period is also known as incomplete period because there are some gaps which are left for undiscovered elements. Okay, in seventh period. So first period is the shortest period with 2 elements. Second and third short periods, fourth and fifth long periods with 18 elements in each. Sixth period is the longest period with how many elements? 32 elements. Okay. Now, next comes the definition of lanthanides and actinides. Let me see this. Okay, next comes the definition of lanthanides and actinides. So you make a note of one question. What do you mean by lanthanides and actinides? Okay. So first, let me explain what are lanthanides. 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 The elements from atomic number 57 to 71 are said as lanthanides. Okay, the elements from atomic number 57 to 71 which are kept separately in the modern periodic table are known as lanthanides. Okay, the name is given so because the first element of this series is lanthanum. Lanthanum. Lanthanum, symbol La, with atomic number 57. Okay, so lanthanides means the elements from atomic number 57 to 71 which are kept separately in the modern periodic table. The name is given so means this, the name is given lanthanides because the first element of this series is lanthanum, whose symbol is La, capital L, small a, and the atomic number of this lanthanum is 57. Next is actinides. 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 The elements from atomic number 89 to 103 which are kept separately in the modern periodic table are said as actinides. The name is given so because the first element of this series is actinum. Actinum. Okay, Actinum, symbol Ac, actinum, with atomic number 89. So lanthanides and actinides we are done. Okay. Next comes what is there? Diagonal relationship. Okay, write down another question. What do you mean by diagonal relationship in modern periodic table? Okay, so answer is diagonal relationship. You have this is second period. This is diagonal relationship is the relationship between the elements of second and third period along the main diagonal. Main diagonal means this is your main. Suppose this is your rectangle. You have two diagonals. Main diagonal means from left to right. Okay. So relationship between these two, these two, these two, these two, these two, and these two. Fluorine and argon, it is not applicable for fluorine and argon. Okay, because fluorine is halogen, argon does not take part in chemical reaction. It is inert. Okay, so diagonal relationship is the relationship between the elements of second and third period which lie along the main diagonal. This main diagonal means from left to right. Okay, so there is a diagonal relationship between lithium and magnesium. This some physical and chemical properties of lithium is similar to that of magnesium, and similarly this beryllium to some extent it resembles aluminum in chemical and physical properties. Okay, so this relationship is known as a diagonal relationship. Next topic is there. What do you mean by periodicity? Okay, so what do you mean by periodicity, and what is the cause of periodicity? So you write down that question. Periodicity. Periodicity means the repetition